Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 10, Angle Problems Solving Equations. A little bit of geometry going on here. This is different. Okay, here we go, solving equations. What's going on here? Let's go back here, okay. Angle facts and definitions, adjacent angles. We're going to put angle facts here. And then here's a diagram I'm going to mark up, hopefully, for you to understand using color. Okay, so our first definition is adjacent angles. Okay, adjacent angles. Basically means angles that are next to each other and they share one common ray. So here it says two angles, angle BAC. So I'm going to color code this as I go. And in order to read an angle, you say you say angle for this symbol. So you say angle, BAC. And what you do is you start at the B, and then you go to the next letter that they said, which was A, and then you go up to C. So that's angle BAC right there in red. Okay, so this is angle BAC. And angle CAD. So if I start at C, go to A, and then over to D, the green one is angle CAD. So mark that green. With the common side AC. So as you can see, AC is right here, and the red angle and the green angle have that in common. They both use that side as one of their sides for the angle. Okay, they're adjacent and angles. See, they're adjacent angles if C belongs to the interior of PAD. So then C has to be inside the larger angle BAD. Angles A and B are adjacent angles. Angle BAC, BAC, and CAD are adjacent angles. So we can either name an angle using 3 points on the line, and they're used as their capital letters, or if we name an angle interior, then we use a lowercase a or a lowercase b or whatever, and the lowercase is the letter that you're going to put inside here. Okay. Naming it BAC or just simply angle A using a lowercase, not capital. Okay, so the next one is vertical angles. Okay, so vertical angles are two angles, are vertical angles or vertically opposite angles if their sides form two pairs of opposite rays. Alright, so there's a lot of terminology here. So, for instance, let's say A equals B. So this is angle A, and they're saying it's congruent to angle B. Okay, I don't like the equal sign here. I would prefer a squiggly line over top. That means A is congruent to B. If they were equal, they'd be in the same location, and they are not equal. Two angles are vertical angles or vertical opposite angles if their sides form two pair of opposite rays. So CD goes like so. So this is C. I'm recreating it. CD is right here. Now if I go from C straight the opposite direction and make that straight and then go over here, that's E. So CE is a ray, and we write an arrow over top to say ray CE, and then ray CD. And the first letter is where we start. So we go from C to D is in this direction. So we go from C to E in this direction. Ray CD, ray CE. Ray CD, ray CE are opposite rays. Okay. Same goes for ray CF and ray CG. And they form a straight line by making opposite rays. So what they're saying is if two set pairs of opposite rays form angles, and the opposite angles are congruent. So this angle here will be congruent to this angle. Okay. Next one. Angles on a Okay. Angles on a line. The sum of the measures of two angles that share a ray and form a line is 180 degrees. So here they're showing angle A plus angle B equals 180 degrees. Or you can say the measure of angle ABC plus measure angle CBD equals 180. Okay, so when they say share the same ray, here's ray BA, here's ray CB or BC. Ray BC is also used to form angle CBD. So that is a shared angle. So I should use black, it's hard to see on these. So there's angle ABC in red, and angle CBD is in green. And they share ray BC, and ABA and BD are opposite rays that form a straight line, and therefore they are two angles that form a straight line, or are on a. Okay, angles at a point. The measure of all angles formed by three or more rays with the same vertex is 360 degrees. So here they're saying that angle A plus angle B plus angle C equals 360 degrees. Or if we name it the measure of angle BAC. So remember, in order to write this, we start at the first letter B, we go to the next point A, and we go over to the next point C. That is angle BAC. Green. So that's green. Then we have the measure of angle CAD, which I'll do in red. So we start at C, we go to A, and we go over to D. That is CAD. So they're sharing AC, so BAC and CAD are adjacent angles. They're sharing a common ray. And then finally, we're going to have angle DAB. So if I start at D, go to A, and then up to B, I now have angle DAB that shares AB with angle BAC, and it shares ray AD with angle CAD. Okay, so this can get confusing, but there's a lot of stuff going on here. So what this is saying is angle A plus angle B plus angle C equals 360 degrees, because if I start here and go all the way around, it makes a full circle, and that's 360 degrees. And that's why if you're a skateboarder, if you do a complete rotation in the air, it's called a 360. Okay, so here we go. Opening exercise. Use the diagram to complete the chart. Name the angles that are vertical. Okay, so I'm going to just do a few. I'm not going to do them all. There's more than one. I see that I have a ray going this way and an opposite ray going this way. Okay. There is also a ray AC and an opposite ray ED that form straight lines. So the purple line and the red line are forming two angles that are vertical. So it's angle AEC. So angle AEC and angle BED are vertical angles, and we know they are common. So there's 53 degrees, and there's 53 degrees. Okay? So as I do this, I'm going to erase the diagram so it doesn't get too messy. Adjacent. Two angles are adjacent if they share one common ray. So here's where naming stuff comes in really handy. If I know how to name things, this is angle AEC. I'm just picking this angle. Angle AEC and angle, well, I need this EC to form an angle with something else, or I need this EA to form an angle with something else. Both directions. So now I'll change to blue, and I will go up here and I'll go CEF. Okay, so AC, or EC, I'm sorry, is the shared ray. And if you notice, EC is in the name here, CE is in the name here. So if we see two letters next to each other, order doesn't matter, and we know that the same ray is being used in both angles, and that will form an adjacent. Okay. I know this is a lot to digest. This is going to be painful for some, but okay. Angles on a line. Okay, so where do I have straight lines? Well, I've got a straight line here. Notice here I can go up to here, but I can't continue straight. There's nothing there, so there is no straight line there. If I started here and went down to E, I can't continue. There's no line there, so there's no straight line there. But I have a straight line here. So that's what I'm going to work with. Okay. So I'm going to form an angle with this. It can be any angle. I'll do this, angle CEF. And angle, change the color of that second angle. And angle, let's do it in red. So I have CEF. I need FED right here. And that forms this straight line right here. Okay. Angles at a point. Okay. Recall. Go back. Angles at a point are three angles that add up to 360 degrees. Three or more angles, I believe it did say. Let's make sure. Okay. Measure of all angles formed by three or more rays with the same vertex. So yes, three or more rays. All right. So if I start here, CEA, so I'd say angle CEA plus angle AEG plus angle GED plus angle DEB. Still not there yet. Plus more colors here. Let's see. This color. Angle GEF. It's kind of hard to see, so I better pick darker for the next one. And how about, oh, I don't know. Just light green. And then finally, FEC. So just see now. And all that sums up to 360 degrees. Okay. So there's an angle, angles at a point. So example 1 says, estimate the measure of angle X. Okay, so now we're looking at this diagram here. Estimate the measure of angle X. So I'd say that's, oh, I don't know, it's estimated at 45 degrees. It looks about that. Just keep in mind that this is 90. It looks like half. Okay, so I'm just estimating 45 degrees. And it says write an equation for the, oh, so in a complete sentence, describe the angle relationship in the diagram. Okay, so angle BAC and angle CAD are angles on a line, and their measures have a sum of 180 degrees. Okay, so let's point this out to you. Angle BAC is right here. Okay, and angle CAD is right here. So they're adjacent angles that form a straight line, so they're called angles on a line. And we know that they add up to 180 degrees. Okay, they're also called a linear pair. That's another way to say it. All right, so now it says write an equation for the angle relationship shown in the figure and solve for x. So now we're going to start using algebra in the geometry to solve for missing things. Okay, so that's why we take algebra before geometry. So we have to write an equation for the angle relationship shown. So there's an x degree here, there's 132 here. So the first thing I would say is the measure of angle BAC plus measure of angle CAD equals 180 degrees. Okay, I want to make a statement of what I have here. Then I'm going to substitute in my givens. Well, the measure of angle BAC is x degrees. So I'm going to say x plus measure of angle CAD is 132 degrees. X plus 132 degrees equals 180 degrees. In order to solve for a variable, we do the inverse operation to get across an equal sign. The inverse of addition is subtraction. What I do to one side, I do to the other. X plus 132, 132 minus 132 cancels. I'm just simply left with x plus 0 or x equals, and then I subtract here and get 45 degrees. Okay, so the measure of angle BAC is 45 degrees. Okay, and it says to confirm with a protractor, but we are not going to do that at this time. Or are we? Now I'm beginning to think I probably should. So I have this little tool up here. Here's the protractor. Okay, and let me erase all of this. And go get my protractor that's at the top of the page. Move it down. And if I put that protractor right here on that line, on that dot, okay, and if I draw a line from here up, see there's my C right here. C is right here, but we have to continue up, and it would be 45 degrees. Okay. Oh, not 45. I was going to say that looks a little off, so I'm glad I checked it with the protractor. I noticed an error in my calculation. Alright, I subtracted incorrectly right here. Okay, 10 minus 2 is not 5, it's 8. 7 minus 3 is 4. X is 48 degrees. That makes more sense because it does look like it's going to hit. If I draw this up here, it looks like it's going to hit right there. Okay? Okay, I just figured out how to use this thing, and I don't have to estimate. I can actually just use this tool here. If I bring this over and put it on C right there, and you do see it is exactly 48 degrees. It's pretty nifty. Alright. Okay, so here it says in a complete sentence, describe the angle's relationship in the diagram. So I say angle BAC, and I will color code it. Angle BAC is this first one. Angle CAD is the red one. And angle DAE is the blue one. Okay, so the green plus the red plus the blue, these are adjacent. These two are adjacent. And the three of them form angles on a line. Okay, so angle BAC, angle CAD, and angle DAE are angles on a line, and their measures have a sum of 180 degrees. So now it says find the measure of angle BAC and angle DAE. So I would say the measure of angle BAC plus the measure of angle CAD plus measure of angle DAE equals 180 degrees. The measure of angle BAC is 3x. 3x plus, now right here you see that little square there. That means 90 degrees, so I'm going to put 90 degrees. And then angle DAE is 2x. And they all equal 180 degrees. Okay, so now I'm going to combine my like terms. 3x plus 2x is 5x plus 90 equals 180 degrees. I'm going to subtract 90 degrees from both sides. And these cancel, and I get 5x equals 90 degrees. And divide by 5, that cancels. Divide by 5, and I get x equals 5 goes into 9 one times, 5 goes into 48 times. X is 18. Then I go back and read the question. Find the measures of these two angles. So the measure of angle BAC equals BAC 3x. So therefore the measure of angle BAC equals 3 times 18. And the measure of angle BAC equals 18 times 3, which is 54 degrees. Okay? Now I have the same for DAE. The measure of angle DAE equals 2x degrees. So the measure of angle DAE equals 2 times my x, which is 18. So the measure of angle DAE equals 36 degrees. Last thing I do is check my work. 36 plus 54 is 90. 90 plus 90. Checks. Okay. Example 2. In a complete sentence, describe the angle relationship in this diagram. Okay. So we have we have angle AEL. AEL. There's angle AEL. We have angle LEB right here. Are angles on a line. Okay, see that straight line? AEB is a straight line. And their measures have a sum of 180. Angle AEL and angle KEB are vertical angles, because that's a straight line, and this is a straight line. Okay, and are of equal measurement since they're vertical. Write an equation for the angle relationship shown in the figure and solve for x and y. Find the measurements of angle LEB and angle KEB. Alright. So there's a couple of different ways I can do this. I can find x because that's angles on a line. So I can say the measure of angle AEL plus the measure of angle LEB. Okay. AEL is the red angle, LEB is the green. They're angles on a line, so they add up to 180 degrees. Then I substitute in my givens. Angle AEL is 144 degrees, plus measure angle LEB is x degrees, and they add up to 180 degrees. If I subtract 144 degrees from both sides, I solve for x. These cancel, and I get x equals 36 degrees. Okay, so I'm going to write that right here. This is 36 degrees. There's two ways I can find y now. I also have a linear pair here, or I should say angles on a line. So I could take 36 plus y equals 180. Then I also have this here, so let's use the information they gave us. Angle AEL and angle KEB are vertical angles and they're equal measurements. So the measure of angle AEL equals the measure of angle KEB. Okay, and the measure of angle AEL is 144 degrees, and the measure of KEB is y. So y is 144 degrees, and x is 36 degrees. So we found the measure of angle LEB because that's our x. That equals x. So LEB is 36 degrees, and the measure of angle KEB is my y, and that is 144 degrees. Okay. Exercise 2. In a complete sentence, describe the angle relationship in the diagram. Okay, in a complete sentence, describe the angle relationship in the diagram. Here's our diagram. And as I've done before, I'm going to color code these for you to help you out. Angle JEN Start at J, draw to E, and then go up to N. There is angle JEN. Then angle NEM. NEM is this tiny little slice right here. Are adjacent angles, and added together are the measure of angle JEM. Okay, so JEN plus NEM. So look what they're doing. JEN plus NEM. So you can ignore this N and that E, and they are the measure of JEM. JEM. So the E repeats, the N's disappear, and that's kind of how you read these. Okay, so there's actually a trick in reading angles. You know these two are adjacent because you have EN and you have NE. And if you just take JE, they're common vertex, and then the last letter over here, that's the name of the two together. So angle JE now, and angle K, now let me use a different color. Angle KE, KEL are vertical angles and are equal. Write a relationship equation for the angle relationship shown in the figure. Okay. So this equals 85 degrees, and this whole thing equals 85 degrees. Okay, so we do know that. So we know that the measure of angle JEN plus the measure of angle JEM equals 85 degrees. So if this is 85 degrees, its vertical angle across from it, vertical angles are equal measures. They're congruent. So this whole thing is 3x plus 16. So JEN is 3x, and measure of angle JEM is 16 degrees, and they have to total 85 because they're congruent to their vertical angle. So when I do the algebra now, I subtract 16 from both sides. I get 3x equals, and 15 minus 6 is 9, 7 minus 1 is 6. 3x equals 69, divide by 3, divide by 3, the 3's cancel, I get x equals 23. Okay, and then go back and read the question. Write an equation for an angle relationship shown in the figure. Solve for x. I'm going to stop the video here. I will do part 2 in a separate video. This is quite lengthy, so stay tuned for part 2.